Hello, everybody. Today we're going to be talking a little bit about parsing Bitcoin transactions with Clarity. One of the big selling points and one of the big features of Clarity is that it allows you to have read access to Bitcoin on-chain in your smart contracts. And so today we're going to go over a little bit about what that actually looks like. I'm going to start off here in the stacks documentation because what this really all comes down to, this functionality, is contained within this get burn block info function. So the way that Clarity actually has access to Bitcoin state is, as part of the block production process for stacks, what's going to happen is the core stacks node is going to take in the information from the Bitcoin block that it is currently a part of, and it's going to write that to a distributed database that the Clarity implementation, the Clarity functions then can read directly from. And so this get burn block info function, what this is going to do is you can pass this a block height. And what this is going to do is pull out the header hash of that block. And we can actually do a ton with just this header hash. Because of the way that Bitcoin works, because of the way that cryptography works, there's a lot of deterministic math that happens behind the scenes and generating all of these hash values. And so what we can do is we can take this header hash value and we can construct a bunch of different data, and we can actually then use that data to verify that a particular transaction did or did not occur on the Bitcoin chain. And then because of the way that Bitcoin transactions are constructed, we can actually take a raw Bitcoin transaction and deconstruct it directly within Clarity to pull out all of the different data contained within that Bitcoin transaction. So we can pull out the inputs, the outputs, we can figure out what type of transaction it is, all that good stuff. And so today we're going to go through the process of how to use Clarity to parse the data within a Bitcoin transaction. We're not going to have time to go into all the details about verifying the Bitcoin transaction within the code, but at the end, we're going to talk about at a high level how you would go about verifying that Bitcoin transaction, because there's a couple different pieces that come into play there. But ultimately, it all comes down to this get burn block info function within Clarity. That's how we can do all this directly on chain. And then there's a bunch of other operations that we can conduct within our Clarity smart contracts that will help us to take this header hash that we're getting from this get burn block info function and use that to actually calculate whether or not a transaction actually occurred. So the first thing I want to take a look at is this Clarity Bitcoin.clar file. And big shout out to Jude and Friedger who worked on this library, but this Clarity Bitcoin library that you can find on GitHub, this contains a bunch of functions to make it a lot easier to actually work with Bitcoin transactions in your Clarity contracts. So the first one we're going to look at here is this parse WTX function, and this stands for witness transaction. And so what this is going to do is this is going to allow us to parse out the contents of a SegWit transaction. And you can see here we've got two parameters. This first one here, this is just going to be a raw transaction hex, and we're going to look at what that looks like in just a second. The second one here, this is just a Boolean to say, do we want to calculate the transaction ID from this transaction hex or not? And this looks like a lot, and it is doing a lot, but what it's actually doing conceptually is relatively simple. And all it's doing is it's calling a bunch of different internal functions. So you can see all of these variables being assigned here. It's calling a bunch of internal functions to just pull out each individual piece of data from that raw transaction, and then we're just returning it right here. And so this function is how we can actually parse out a SegWit transaction and get all the individual pieces of data that are contained within that transaction. Where this gets really interesting is when you pair this helper function with another one called was SegWit transaction mined compact. And there's a lot of data being passed here. And all of this data is what we need in order to basically construct the mathematical proof that proves that this transaction that we're passing in was actually mined in this Bitcoin block height that we're passing here. So what we're passing here into this function is the block height, the raw transaction itself, the block header, and then there's a bunch of stuff here related to how we can construct that proof. So one of the key pieces of functionality here that this library uses is what's called Merkle proofs. And what this does is at a high level, it basically allows us to mathematically trace the contents of an entire block, and we can trace that all the way back up to that block hash that we got from that original Clarity function. And we can use cryptography and math to sort of place this transaction within that Merkle tree and then do all the calculations to calculate it back up to that Merkle root and make sure that they match. And if they do match, then that means that this transaction was actually included in this block and was actually mined on Bitcoin. Because once we get back to that source of that get burn block info where we have that original block header hash, if that if our result from verifying this transaction and going through that process matches that, then we know that we are correct and that this transaction was actually contained in the actual Bitcoin block itself. And so where this gets really interesting is where you want to build a Clarity contract that reacts to some sort of Bitcoin transaction, but you don't want to take that action unless you are absolutely positive that that transaction actually occurred on the Bitcoin side. And so this library allows you to do that. And there's a lot of work that goes into constructing and getting all of this information. Some of it you might have to construct manually. Some of it you might be able to call for a specific Bitcoin API, depending on what API you're using. We're going to dig into that just a little bit in this, but right now I'm working on a library to basically make this process a lot easier and a lot more simple. And the goal here is really how can we make it so that a developer can just pass in this transaction and the block height that they want to verify it in. And we can use a combination of constructing these Merkle values ourselves and a combination of calling Bitcoin APIs to get that data ourselves. Because remember, it is technically possible to construct a Merkle proof manually within Clarity, but that's not a good idea because it's very computationally expensive. We don't need to do all of that work within the contract. The only thing we need to do on chain within the contract is verify that that information is accurate. So we can do all of this construction off chain with a JavaScript library or whatever we want to use for that. And then once we have that data, we can pass it to this function, and this function is in charge of verifying that it occurred on chain. The verification is the only part that we need to occur on chain. And so there are different ways that we can get all this data that can be off chain and can use external and third-party APIs and can use our own code if we want to, because the verification is what is actually happening on chain. So a sample workflow for this would be, let's say that we want to allow somebody to mint an NFT, but we only want to allow them to do that if they sent a specific amount of Bitcoin to a specific address. So what we can do here is we could set up something like a chain hook on Hero's chain hooks where we have this sort of if this then that setup where we're saying if somebody sends this amount of Bitcoin to this address that's encoded with this op return value, then what we're going to do is we're going to trigger that chain hook. And on the back end of that chain hook, we can call a Clarity function that we set up that will do two things. The first thing it's going to do is it's going to verify that the transaction actually happened by passing all this data here. And then the second thing it's going to do is it can go back up to this function that we were looking at first, and it can actually parse the transaction data out and then return it here, and then we can do something with it on the back end. So in this case, what we might want to do is first verify that the transaction existed. And then what we can actually do is we can, from the input here, we can get the Bitcoin transaction that, or excuse me, the Bitcoin address that sent this transaction. We can actually then convert that into a Stacks address because they share a similar derivation path, and every Bitcoin address automatically has a Stacks address associated with it by default. So we can basically mint to the first input, and that can all happen where the user side of things, all they're doing is they're just sending a Bitcoin transaction. So that's kind of the big picture overview of how this process works. I have a very simple interface right here to demonstrate what the parsing part of this looks like. And right here, I have this raw transaction hex. And this doesn't look like anything fancy, but the cool part about this is that it's actually calling that Clarity smart contract on the back end. And so we can pass in this raw transaction hex here and hit parse transaction, and it's calling that read-only function, that parse witness transaction function that we looked at, and it's giving us a lot of data back here. And what the Clarity function is going to do is it's going to give us this information in its encoded format, and so it's going to be pretty difficult for that to be human readable. And so a lot of what I'm doing here is I have this front end function that's going through and it's formatting all of this to put it in more of a human readable format right here. So what we can see here, we can look at a couple different things. I'm actually going to open up BitScript and teaser for the next session. Jesus from BitScript is going to be going over Bitcoin script, but BitScript is an excellent tool to be able to just work with and understand Bitcoin transactions. And so what I'm actually going to do is I'm going to take this raw transaction that I have, and I'm going to bring it over to BitScript because it has a really good interface for deserializing that and helping us understand what's actually going on. So we can look at this first part right here. And this first part of the raw transaction is a version. So in case you're not familiar with how Bitcoin raw transactions work, all of this stuff that looks like just a bunch of random letters and numbers is actually encoded information that's telling us exactly what content is included in that Bitcoin transaction. And so we can look at that piece by piece here and we can see the version. This tells us what type of transaction it is. If we go back to our code here, Clarity Bitcoin library, you can see that what it's doing here is it's going through this raw transaction and parsing out this data in a very similar way. It's just getting each chunk and returning each chunk to us. And there's a ton of complex stuff that's happening in all of these internal helper functions to get all this. But at its core, that's what it's doing. So we get the version right there. And we've got a couple other pieces of data. Flags, this is for SegWit functionality. We've got the input count. It loads here. We've got that transaction ID of the previous transaction, so the input that created this UTXO. We've got the index of the UTXO that's unlocked, some Coinbase data. Because this is a Coinbase transaction. We'll check that out in just a second. And then we've got a bunch of information about the outputs. And from all of this, we can parse out several things. We can parse out the amount of Bitcoin that's being sent. We can get any op return data. So if we go back to this interface right here, we've got the version, we've got the inputs listed here. You can see right here, the previous transaction ID is a bunch of zeros. That's how part of the way that we know that this is a Coinbase transaction is because there is no previous transaction ID to serve as the input for this one. And then we've got two UTXOs here. The first one is a 50 Bitcoin output, and this is the actual like Coinbase amount that's going to be sent to the miner for this transaction. And then the second one is op return here. And miners can encode data within op return transactions. But the reason this is cool is because if we want to signify something with a Bitcoin transaction like that chain hook scenario I was talking about just a minute ago, I can, on my front end in my application, I can use a JavaScript library to construct a Bitcoin transaction in a specific way so that all the user has to do is just sign in and authenticate with their wallet and then initiate that Bitcoin transaction. And some of this op return data can be automatically encoded within that. So then I can pick it up on the back end and do whatever I need to do with it in my Clarity code. And so that's a little walkthrough of what this is actually parsing out. And we've got the lock time here. And there's no lock time on this particular transaction, but we can encode that there. And so that's all being done through a combination of calling this function. So we have our interface right here, and all this interface is doing is it's just calling this handle parse function, which then is in turn getting that Clarity Bitcoin contract and calling the parse WTX function, passing in the raw transaction, and then passing in the Boolean for if we want to return the transaction ID with it or not. And then what's going to happen is we're going to call this format transaction data function. And this is where a lot of the work is happening in this particular application in order to make it a little more human readable. And all we're doing here is we're going through and again, getting all of the raw data that's returned from the Clarity contract, and we're just parsing it out in a way that makes it a little bit easier to read, converting some of the values from their encoded versions into their human readable versions, and just displaying that data in a more user-friendly way. And so, like I mentioned earlier in this workshop, currently working on a library to make all of this easier. This code right now is not live on GitHub yet, but it will be published as a repo, just as kind of like a Bitcoin Stacks playground so that developers can kind of experiment and see, what are the best ways to actually play around with Bitcoin transactions from a Stacks application. And so I want to take a real quick detour to show you how I actually got this all working and got this all set up. Because one thing that I've noticed that is a bit confusing is, we know that Stacks runs on top of Bitcoin, and we know that the underlying Bitcoin chain is there, but actually interacting with it, especially in a development environment, can be a little bit tricky and a little bit confusing. And so I want to walk through how I actually did that so that you can then go and use that as a base to then run your own experiments and build your own projects using this concept. And so what I have right over here is I have an instance of Clarinet's DevNet running. So if you're not familiar with Clarinet, you definitely should be because it is one of the most valuable tools for actually building on Bitcoin. But Clarinet, if you're familiar with Solidity and Ethereum development, Clarinet can be thought of as similar to like a hard hat or a Foundry. But it's going to allow you to develop locally. And one of the cool things that it does is it's got a feature called DevNet. And what this does is this is going to set up a localized mocknet stacks that's attached to a regtest Bitcoin node. And what regtest means is there's Bitcoin mainnet, there's Bitcoin testnet, which is the public testnet, and then there's Bitcoin regtest, which anybody can spin up. It's basically a private testnet that you can set up however you want. And so that's what DevNet uses under the hood, and that's what we can actually interact with to get some of this information from Bitcoin. And the way that we do that is Clarinet uses Docker under the hood, and it runs all these services in different containers. And so we've got a couple different things here that are important to know. One is the Stacks Explorer. So I'm going to open this up real quick. And this is the same Stacks Explorer that you're likely familiar with. But if we go over here and switch the network to DevNet, well, now we can actually see the blocks that we're producing locally here. And we can see all of these different blocks. So for example, here's that Clarity Bitcoin contract deploy that we just looked at. So that contract is deployed. That's why that front end interface was able to work. This is probably pretty familiar to a lot of you, but this is how we can just look at the stacks blocks that are running locally. And if we close that, the other thing that's also interesting is that we have this Bitcoin Explorer URL. And if we pop this up, this is running an instance of this regtest Explorer, which is an open source library. You can see the GitHub link right down here. It's just a Bitcoin RPC Explorer. And this not only gives us access to the blocks, the Bitcoin blocks that are being produced, but if we go over here to tools, we can see an RPC browser. So we can see all of the different RPC commands that are available to us. And then we also have API access right here. So remember back earlier when we were talking about how can we actually verify a Bitcoin transaction? Well, some of that information we're going to have to get via something like an API. And so we can look at the API endpoints here and say, okay, what data do I actually have available to me that I can get with this API? And what data do I need to then take and then construct my own version of using a Bitcoin JavaScript library or something like that? And so we go back to right here in this interface that I have. Where did I actually get this raw transaction hex from? And that's the process that I want to go through real quick, because doing something like this is how you're going to be able to kind of build your own applications that connect with and read Bitcoin like this. So I'm going to open Docker Desktop, and I was saying earlier, Clarinet uses Docker in the background, and so we've got all these different containers running. Well, if we go right here, we can see that we can get directly into our Bitcoin node. So if I go in, you can do this from the command line too, but I like Docker Desktop. But if I go in here and go into exec, this is actually going to give me shell access to this container that's running. And so I can use the Bitcoin CLI directly from in here. So if I do Bitcoin CLI, I'm going to pass it the regtest flag. And I need a couple other flags too for authentication, but I'm going to do RPC user. And DevNet has a built-in authentication credentials of DevNet. So RPC user DevNet, and then RPC password is DevNet. And what I want to do is I want to run the list unspent. And this is one of those RPC commands that we have access to. If we go back to this Bitcoin Explorer, we go to the RPC browser, and we find list unspent. We can see that right here. And you can actually kind of use this execution environment. I prefer to just use the command line because I find this a little bit clunky, but this will tell you what this command is actually going to do. And what this is going to do is returns an array of unspent transaction outputs. And so what I can do from here, close this again, so I can go back to my container. And if I run this, then I'm going to get a list of all of the UTXOs that have happened on my local DevNet Bitcoin chain. So then if I take one of these transaction IDs and go back to this Bitcoin Explorer, now what I want to do is I want to go to the API because I want to get some information about this transaction. So I'm going to click on this API endpoint. It's turning an error because it's got a default URL here that we don't actually use. And I'm going to paste in our transaction ID, and then I get a bunch of data back from that. And one of these pieces of data is the hex. And this is that raw transaction output that we're using right there. And so this is how you can go from just transaction ID to raw transaction. And then you can do a bunch of different things from there with this API. So let's actually go back to where I just was. Paste this in. The other thing that I get here is a block hash. And so from just a transaction ID, I can get the raw transaction hex, and then I can get the block hash that it was included in. And if we go back to the same API, we've got right here this endpoint where I can get block information by passing in the hash. And so I can go here, pass in that block hash that we just got, and this is going to give me a bunch of information about the block. And this is the kind of stuff that I can use to then go in and construct the data that I need for that transaction verification. So we've got all of our Coinbase transaction information here. This is some of the stuff that we need in this was SegWit transaction mine compact function. So you can see here CTX, this is the Coinbase transaction, Coinbase proof. Some of this Merkle stuff, you're going to have to take information from the transaction and from the block, and you're going to have to manually construct that. One thing that I've actually found to be pretty helpful at this is AI. You obviously have to be careful, but you can really use, specifically, I use Cursor as an editor. What you can do that I found to be very helpful is you can pull in this Clarity Bitcoin library and you can talk to Cursor and say, describe to it what this transaction is doing and use it as a starting point for constructing a function that's going to then generate that Merkle proof information for you. And then obviously you're going to have to go in and you're going to have to refine it and edit it. It's not going to be perfect. But if you can kind of think of yourself as like a sort of a senior developer and your AI is your junior developer, if you can tell it, if you can do a good job of describing to it exactly what you need to do, then it can do a pretty good job of generating the code that you need to construct that. But it's important that you understand how Bitcoin transactions work and how this function works, because otherwise you're not going to understand if the output it's giving you is correct or not, and you're not going to be able to give it good instructions. But I have found that to be a really helpful way of dealing with what can be a lot of really precise, complex programming work here. AI is really good at getting a lot of that long, complex, tedious stuff out of the way so that you can then focus on tweaking it and adjusting it to make sure that it's working the way that you want it to. And so that's what I recommend people do there. But so back to this, we have access to all of that API information. We can get our transaction here, and we can use this Bitcoin API to get all of the information that we need here. And then that's what we can use to actually go back in and get all the information we need, do those transaction verifications, do that transaction parsing, and get all that done there. I do have, really quickly, this is a work in progress still, but if we go back to this, our main UI, I do have a handle verify transaction function in progress here. This is part of this repo that I'm working on. So when I publish this, this will be there for other people to come in and look at. But what this is doing is this is actually going in, like I was talking about, and it's getting the data from the API, like we were saying. And then what we're doing here is we're going down and we're getting all the transaction info, and we have a calculate Merkle proof function here that I think might be implemented in another file. So here's this calculate Merkle proof function. This is not quite working just yet, but this is something that we can do to actually construct that Merkle proof ourselves. And this is where AI can come in and help us out just by getting a lot of the tedious stuff out of the way. And then we can go in and tweak it and test it and see if we can get it to match and verify that the transaction has occurred. You do this with the transaction that you know for a fact has been included, and then you can test and see what's working and what's not. But this is a work in progress, but that's what that's going to do when it's done, is it's going through and it's hitting that API info, getting the information that we can get from the API, and then constructing that Merkle proof. Some APIs, I believe the mempool.space API, they actually provide a way to get the Merkle proof natively in the API, and so that makes it a lot easier. But the local DevNet Bitcoin node doesn't use that API, and so we have to construct it ourselves, which is good practice to be familiar with anyway, because depending on what API you have access to for what project you're working on, you may or may not have access to a Merkle proof endpoint like this. And so this is a way that we can kind of construct it ourselves. But I'll release that when it's done, and then we can kind of add this to the playground. And one other thing I wanted to add here is you might notice that when I'm calling this API, I'm just calling it without a URL root. If we go back to our DevNet, we can see that it's localhost 8001 is where the API is actually running. And if I just run that in my browser, then I can get to it no problem. But if I try to call that directly from my code, then I'm going to get a CORS error, cross-origin resource sharing, I think is what it stands for. But if you're a front-end developer, you've almost definitely had to deal with CORS before, and it's horrible and a nightmare and the most annoying thing about being a front-end developer. And so the workaround here is I'm using Vite. Actually, I'm using Remix, which uses Vite under the hood. But what we can do here is we can set up a reverse proxy on our front end. So, and that will allow us to fix that CORS error. And that's why I'm able to call this API from the front end without running into that CORS error. But the way that this works is instead of, the reason I'm passing the URL like this, instead of typing in, localhost 8001 right there, is because if we go to my vite.config file, I have a proxy set up here for this API endpoint, and it's targeting this right here. And so that's how I'm able to basically bypass that CORS error, and I'm able to call the API from within my front end application. So that is about it for this workshop. Just an introduction to how Clarity can read Bitcoin data, how we can then take that data, verify it, parse it, and use it to take some action on the back end on the Clarity side. I'll be continuing to work on this repo, and the goal is to kind of to turn it into like a starter template or playground for developers that are interested in basically taking a Bitcoin transaction and doing something with it on the back end and responding to it. So over time, I'll be adding chain hook functionality to this. I'll be refining that verification function, getting all that to work. And then ultimately, the goal is to have a library, a JavaScript library where you can npm install the library and just call a Clarity function like this, like the parse or verify functions, and all you have to do is pass in some basic information, like maybe the transaction ID and the block height, and it'll calculate all the rest of this stuff using a combination of API calls and constructing it manually. That's the long-term goal, but for now, we'll turn this into sort of a starter template so that people can take a look at it. The other thing to note is that SBTC will handle a lot of these use cases for us, and it'll kind of abstract away that functionality. And so I think most developers will probably find that using SBTC is going to be the most straightforward way to build the applications that they're talking about. But it is nice to have this because it allows us to have, some optionality with how we're building these applications. If we have a user base that wants to be Bitcoin only and they don't want to have to deal with stacks at all, we can make it so that all they have to do is send a Bitcoin transaction and everything else happens behind the scenes and automatically just through these verification and these if this then that mechanisms provided by Chainhook and all the Clarity contracts. And so it allows us to build applications in a different way. And this functionality of Clarity, this is part of the way that SBTC is going to operate under the hood, is that we'll be able to take as part of the deposit, the SBTC deposit process, signers will be able to check and see on chain, hey, was this deposit actually submitted on the Bitcoin chain before they deposit it on the Clarity side, on the stack side using the SBTC token. So quick look into how Clarity interacts with Bitcoin, how we can read those values, parse them. I'll be sure to release this repo as soon as it's done so that developers can get started kind of experimenting with this and using it in their own applications. But that's it for me today, and thank you, everybody.